Your screen should be saying this meeting was being recorded because at this point the recording has begun. Uh, so, like I said, we are going to finish up talking about, sorry, we're going to finish talking about the axiomatic system. On Tuesday, we said axiomatic systems are just systems where you have rules, because an axiom is a rule. So a lot of games that we play. So for example, if you are someone who likes board games, when you play board games, it comes with an axiomatic system because they'll tell you what materials they have, and then you'll get these lists of all of these rules that you have to follow for every game. No matter if you're playing Monopoly or Life or Scrabble, there's always games. I mean, always rules, and those rules are called axioms. And the axiomatic system is key to geometry because in geometry we have to operate within certain parameters. And we'll talk about arguing our point, verifying our point, and just to kind of recap, that was actually one of the standards. I forgot to mention that. One of our standards for today, constructive viable arguments and critiquing the reason of others. That's part of what we'll be focusing on in this activity. Okay. Just wanted to kind of recap to that. So, no worries about that. We're still getting used to all of this. But yeah, so class starts at 11:35. It's really technically no class exchange between fourth period and fifth period, even though it's 5 minutes between every other class. All right, but anyway, so we are going to explore more of this game. Make sure okay. Had to make sure my screen was proper. So just kind of a recap. In this game, Henry and Emma are playing a ball toss game. To play, Henry and Emma need one spinner, six balls, 50 tokens, and a ball toss board. Spinner down here, spinner's down at the bottom. Ball toss board is above the spinner. And these are the 8 rules. Everything that we're going to focus on is going to be regarding these rules. That is the best circle I have made today. That is a struggle. All right. Everything is going to revolve around these 8 rules. For one, spin the arrow. When the arrow lands on the number, toss that many balls. 2, you must stand 3 feet away from the board to toss a ball. 3, when you get a ball in the hole, you earn the points associated with that hole. 4, you get 1 token for every 50 points you earn. 5, you cannot earn more than 1,000 points during a turn. 6, you lose a turn if you spend a 5. 7, you need at least 2 people to play. And 8, the first person to earn 2,000 points wins. Okay, so those are the 8 rules. So every question that we're going to deal with is about analyzing the rules. That's what we mean by analyzing an axiomatic system. So back to those rules. That's where everything's going to revert. Oops. Oh, wait, let me clear this off my screen. So last class, I believe we kind of made it through the first, just at least discussed the first rule. Uh, oh no, I'm sorry, first exercise, not first rule. Pardon me, first exercise. We're gonna look through exercises 1, 2, and 3 together, and I'm gonna leave 4 and 5 for you to do independently. Okay, so first, exercise 1. Henry argues that some of the rules contradict each other. Do you agree or disagree with Henry, and why? So, and I can't remember exactly which class that was. Someone asked me, what did contradict mean? Could I have someone in the chat put down, what does contradict mean? That is a key word that we're using. What does contradict mean? Go against each other. Exactly. So Henry is saying that some of the rules go against each other. Uh, so obviously, well, not obviously, but since I did the example earlier, I can't actually type anything in. But this is kind of an opinionated question. If you think the rules go against each other, I want you to say and put in there that you agree with Henry, and you are going to state why you believe that. Okay. If you think the rules contradict each other, then you're going to state, I agree with Henry because, and you're going to tell me your rationale and your thinking. If you believe the rules do not go against each other, the rules do not go against each other, you're going to explain the rules do not go against each other, or the rules do not contradict each other because, and you're going to explain why. So, first couple of questions are going to be based on your perception. All right. But what I am looking for more than anything is your logic and your ration or your rationale. Okay. That is way more important to me. That is the most important thing to me. What is your rationale? How did you reach that conclusion? Okay. You're going to hear me talk about that a lot, specifically in this course, geometry. How did you reach that conclusion? Okay. We're going to be making arguments. Right. So give about a minute for that. All right. About another 30 seconds. Give you a little extra time. All right. So, like I said, the first question is an opinionated question. Do you think those rules contradict each other? Explain your rationale. Now, the second question, or second exercise, I'm sorry, it's just a question. Emma thinks some of the rules are incomplete. Do you agree or disagree with Emma? And why? Emma thinks some of the rules are incomplete. Do you agree or disagree with Emma? And why? Do you think that the rules are incomplete? Again, the main thing I will be focused on is your rationale. The most important question to me up there, the most important question up there to me is why. Why is always the biggest key. And also very important to know when the question is asking, do you agree or disagree? There is no right or wrong answer. I cannot tell you what you agree or disagree with. Only thing I could do is analyze your logic. Okay. So I'm not saying you have to answer this way or have to answer that way, but you do have to explain whatever answer you select. If you agree or disagree. So just be aware of that part. That's real. Then if we look at our third question, okay, Henry and Emma find two rules that contain repetitive information. What does repetitive mean? Make sure we dissect these words. What does that word repetitive mean? Okay. Put that in the chat or you can come off mic. What does repetitive mean? And someone sent in a private chat and said that it means again or to repeat. Yes. So Henry and Emma find two rules that contain information that repeats itself. What rules I'm about to say Emma, are Emma and Henry discussing? Explain. Now, give you just a couple of little hints about this one that I did in my other class. I'm a person. So everything we're questioning and we're dealing with are about these 8 rules. So they have 2 rules that contain repeating information. So a couple of things that you might notice, give you a couple of hints. It seems to be a few rules about tossing. You might want to think about that. Tossing the ball. Also, some rules about spinning the spinner. So let's think about that. Might be something with tossing the ball, something with spinning the spinner. And let's write, what rules do you think they are discussing? And explain why. What rules are they discussing? And explain why you believe that is why you believe that is repetitive. So you might notice with these questions, a lot of it is just do you agree or disagree? Because that's where we are in terms of geometry right now. I just want to focus on the axiomatic system, analyzing rules. Because in geometry there are tons of rules. Okay, and it's not that we just make them up. It's what happens in the well, scientifically, it's just what happens. So what we'll do is we will get into those rules and analyze them. So that's why I want to start with this activity, with looking at actual rules, even though the proper name is axioms, but we're looking at rules and analyzing the rules. So believe it or not, this is a very geometric centered activity. Okay. So for the first 3 questions, like I said, I wanted to walk through with you, or 3 exercises. So the first one, which rules argue against sorry, Henry argues some of the rules go against each other or contradict each other. If you agree or disagree, you're going to explain. Emma thinks some of the rules are incomplete. Do you agree or disagree? Then you're going to explain. Henry and Emma find 2 rules that contain repeating information or repetitive information. What rules are Henry and Emma discussing? Just as a hint. They think about spinning the spinner or something about tossing the ball. Exercise 4 is literally pretty self-explanatory. I think rewrite the rules so that none of the rules are contradictory, incomplete, or repetitive. Okay, so not write some clear rules for this game. And what qualities must rules have to accurately describe a game? So think about any game that you play and think about the rules. Okay. So what should the rules have to describe the game and be ready for you to play? Board game, uh, computer game, even if you're just playing like basketball or football, what qualities do you think the rules should have? And can the rules be disputed by players? Now, the player doesn't like the rule, but what about if players argue over rules? Yeah. So this activity is actually due tomorrow. I think I had like maybe three people finish it, but I can't remember exactly which class. But since the majority did not, tomorrow is an asynchronous day. I'm gonna have office hours. I'm gonna have office hours. I'm gonna leave my Zoom link open pretty much all day long, except for lunch. And you can always zoom in to ask any questions, anything you need. Okay. But this assignment is one of the assignments that is due tomorrow. All right. We got two things due tomorrow. This is one. I'm gonna refer back to the other in a minute. I think I even mentioned that I was gonna do some back and forth. So, any question about axiomatic systems or analyzing the rules? So, any questions about this activity? If you feel comfortable with completing this activity, give me a thumbs up. If not, give me a thumbs down. Okay, thumbs up. Let's see. I got a couple of people, a few people. Got some more folks coming in. Okay. All right. So remember, this is going to be due tomorrow. So you know how to access it. And only focus on the rules of the game. You're not actually looking at the game, just the rules. Okay. All right. So going back to my agenda, this uh this mouse sometimes killing me out here. All right. So actually I wanted to at least explain that out for everyone. But now I want to talk a little bit about types of geometry. Okay. The types of geometry. There are two types of geometry. And I forgot to open up something in my Windows. Desmos. What Desmos is a graphing calculator. I'm pretty sure a lot of you are familiar with it. Whenever we graph geometric figures on a Cartesian plane or ordered pair, and this is a Cartesian plane that is on your screen. So like Desmos is a Cartesian plane. Anytime we graph geometric figures on a Cartesian plane, it is called analytic geometry. I'm going to put that inside of the chat. That's not how you spell that. Analytic geometry is whenever you have a coordinate plane. So if you have analytic geometry, it's always going to be with a coordinate plane. So if I wanted to graph, wait, sorry, let me go back. I went to the wrong one. I meant to open up the geometry one. My bad. So if I want to graph something and I have ordered and I have a coordinate plane, anytime I graph anything using the coordinate plane, this is an example of analytic geometry. What makes it analytic is literally I have a geometric shape, in this case a circle, and it is on a coordinate plane. Because I can say, hey, the center of my circle is located at the point -2, 2, and it intersects somewhere at the point 0, -2 on the y-axis. Because I can use coordinates, that makes it analytic geometry. So any geometry that involves a coordinate plane is called analytic. Okay. Now the other type of geometry, I'm gonna cut these off. If I do not have ordered pairs, I'm sorry, not ordered pairs, but I do not have a coordinate plane, this is called synthetic geometry. I'm gonna put that in the chat. So analytic geometry involves a coordinate plane. Synthetic geometry, such as what you see on the screen, does not have a coordinate plane. So the difference is literally, do you have your XY axis or do you not have your XY axis? If you have an XY axis, it's analytic geometry. If you do not have an XY axis, it is coordinate. I'm sorry. If you do not have an XY axis, it's synthetic geometry. Okay. So those are the two types of geometry. Any questions about those two types of geometry? Remember, screen right now is synthetic. I can modify that very quickly, and that's analytic. So analytic currently, synthetic. That is the difference. Okay. All right. What I'm going to do is a little bit of practice on uh, determining the types of geometry. So what I'm going to ask everyone to do is let's go back into our reveal page. Go back into reveal. Once you are in reveal, you'll notice, and I forgot to put this in Canvas, I'll put this up in a second. It says check two types of two checks, types of geometry. You are going to select that. And when you select that, you should see, you're not going to see everything I just showed, but if you select that, you'll have to clear in. It's going to say check, just like the screen right here. We're going to look at, and it's actually, it says one question, it's really four. I don't know why they say one. It's really four questions. We're going to look at two of them together, and you're going to do two independently. Okay? So let's get started. And after you click get started, you should see this image where it just says question one, and you have four pictures. I don't know why they just didn't go question one, two, three, four, but whatever. Not, I didn't program this. Does anyone need help getting to this page or navigating to the check, the types of geometry? If you need help getting to the check, the types of geometry, please let me know. Wait about a minute, proceed from there. Okay. All right. So what we're going to do here is we are going to determine if each picture represents synthetic geometry or analytic geometry. So this first question, you got this picture right here. You have a quadrilateral, four-sided figure. Do we think this is analytic geometry or is it synthetic geometry? Let's put that in the chat. If you think it is analytic geometry, put a number one. Number one, if it's analytic. Number two, if it's synthetic. Do you think that first picture, I think I misspelled something in there, but do you think that first picture is analytic or synthetic? Okay, got to vote for analytic. Anybody else? I had somebody send me a private chat saying analytic. All right. All right. So this uh this quadrilateral four-sided figure it does have an X and Y axis. Because it has an X and Y axis, it is analytic. For those people who indicated number one or analytics, you're absolutely correct. That is analytic geometry. What about this circle? That circle, analytic or synthetic? Analytic or synthetic? Circle R, is it analytic or synthetic? Okay. All right. Got one for synthetic. Another in the chat. All right. Okay. No ordered pairs, no XY axis, just kind of a lonely circle just floating out in space all by itself. Seems very synthetic. Okay. So what you're gonna do is you're gonna just answer those next couple of questions if you haven't already. And literally that's what you're analyzing. Is this analytic or is this synthetic? Okay. So the first one is analytic because it's got the XY axis. That second, so the quadrilateral is analytic. The circle, synthetic. Good. I appreciate those who have commented and made stated what they know. Absolutely right. Right. So occasionally I will have you do like quick checks like this just to kind of verify a couple of things. All right. So on my agenda, this was the check. Wait, where's my agenda? Okay, here's my agenda. All right. So got about 10 minutes left. Oh wow. I think I'm having less computer problems than last class. A couple of things I want to go over. And I'm going to talk about this assignment systems practice review. So first off, for your assignments, let's look at what is coming up and what's due. I think I told you I would revisit those. The check, I forgot to put that it's not in here for whatever reason. I thought it was, but You'll see it on your reveal page, and I'll link it into Canvas. Uh, but what is due tomorrow? Tomorrow is A, the explore using a game to explore axiomatic systems. The 5 questions dealing with the rules that is due tomorrow. Just as a reminder, the vocabulary is due tomorrow. So if anybody forgot about the vocabulary, just to kind of show you, I had to kind of go through a slightly different method whenever I had to read something as a teacher. And of course, my internet is not want to cooperate with me right now. So just as a reminder, when I talk about the vocabulary that's due tomorrow, I know some people have turned it in. I have not started checking it yet because it's not quite due. Uh, you have to answer these first 3 questions. Okay, answer these first 3 questions. So I just wanted to remind you of that. That is due tomorrow, and the exploring axiomatic games is just exploring axiomatic games. And due time is pretty much always midnight or 11:59 p.m. Whenever I tell you something to do, assume 11:59 p.m. unless I explicitly say something different. And all right, now your next assignment that is actually going to be due on this upcoming Wednesday to kind of summarize all this geometric systems practice. I might have to open it up a little bit different. All right. I'm not about to link everything. You probably should, like I say, everything's going to come up different on my end. But here's what you are going to do to kind of put all of these concepts together. But I'll probably do a series of images, right? Okay. And then, hey, this is what it should look like. But the main thing, and I'm going to talk a little bit about this on Monday, just to kind of review. All right. So you are going to make conclusions using rules and information. You're going to make some conclusions, draw some conclusions using rules and information. So we'll look at number 1 together. The Badgers basketball team has 10 players. During practice, half of the players wear red jerseys numbered 1 through 5. The other half wear yellow jerseys numbered 6 through 10. The yellow team wins the practice game 32-26. All right. So 10 players, half wear red, number 1 through 5, half wear yellow, number 6 to 10. The yellow team wins the practice 32-26. Some important facts. Kylie wears number 5 and scores 9 points. Kelsey's team wins the game. Marie and Kylie are on opposing teams. I don't want to write this. We got to change up everyone's work. So I'm going to put some information in the chat as soon as I get my cursor. So the question is, use the axiom to make 3 conclusions about the games played. I want to give y'all one conclusion, and I want y'all to draw some other conclusions. See, together we could draw some other conclusions. Just so we could see what this looks like. All right, so one conclusion. If we look at that first point of interest, first point, Kylie wears number 5 and scores 9 points. So if Kylie wore number 5, a conclusion can be Kylie was on the losing team. How do you think we could make that connection? How could I automatically know that Kylie was on the losing team? Just using those rules and that information. Slide it right in. How did we know Kylie was on the losing team? I have to link a couple pieces of information together. But Kylie was on the losing team. How can that be a conclusion that we can draw? It's not the only conclusion. How can we draw that conclusion? Any, let's see. Well, let me change this up. Any other conclusions that we think we could draw? Come on, Mike, or you can put it in the chat. Any other conclusions that you think can be drawn? Okay. Can we come up with another conclusion other than Kylie was on the losing team? We know Kylie's on the losing team because she wore number 5, and the red jerseys wore number 1 through 5. And the yellow team won. So that means the red team had to lose. Okay. All right, this is gonna take a little bit of this is what I like to call the productive struggle. All right. Because often this is what geometry is. We're going to take rules and we're going to draw conclusions based strictly on those rules and use those rules to justify whatever conclusion we draw. So, for example, another conclusion, and how we could draw that is that Marie and Kelsey are teammates. Oops, that's not how you spell that. Marie and Kelsey are teammates because Kylie and Marie are on opposing teams. Kylie lost, was on the losing team. Marie must be on the winning team. If Marie is on the winning team, she must be on the same team as Kelsey. Kelsey's team wins the game. That's another conclusion we can draw. We don't want to overlook things that seem so obvious because literally sometimes the information we'll state will be the information that we're given. And then another conclusion that we can draw is that Marie and Kelsey were numbers or a number or a number from 6 through 10. That's what the winning team did. The winning team wore numbers 6 through 10. And since they're on the winning team, they wore they wore a number from 6 to 10 in their jersey. And here's the fourth one, even though I didn't on the extra 3. Their jersey was yellow. All right. Okay. So it's about 12. I think I got just a few seconds left. So just kind of a recap. I'm gonna spend a little bit more time on this, and then this will be part of our activities for next week. But what is due tomorrow? You could put this inside of your when you're doing your timesheet. Make sure you get the vocabulary done. Explore using the game. Sorry, using the game to explore axiomatic systems and the knowledge check. Because the knowledge check is going to be due on Wednesday. All right. So you have a few activities you could be doing, a few assignments. So definitely work to be done. And let's get to it. Tomorrow is my open office hours. If you need anything, just you can come online or you can send me an email and we can work anything out from there. All right, folks, it's 12:30. It is time for sixth period. So wherever you're supposed to be, sixth period, let's go log into that class if it's meeting today. And I hope everyone has a great day. Peace, everybody. Take me a while to log off of this thing. Oh, there it is.